Hello and welcome to episode 97 of Linux Dev Time. I'm Joe.
I'm Amalith.
I'm Kevin.
And I'm Andy.
Good to talk to you all again and welcome back, Amalith.
Hello. It's good to be back.
So today we're going to talk about test-driven development. And Andy, you have assured us that this is not going to be boring, so go for it.
I can't guarantee it's not going to be boring, but I can start by making the case for testing, and then we could talk a bit about test-driven development. So to make the case for testing, every programmer or anyone who's tried to write a program, which makes you a programmer, knows that you never get it right. You always have to try out your program, and you always find you've done it wrong, and you have to fix it. So automated testing is basically automatically trying out your program after you've made a change to it to make sure that it does what it does. And once you get into testing, you can't imagine writing code without having tests that make sure it works.
It's also a really great way to sneak in backdoors, isn't it?
Ideally, don't use binaries.
I mean, it's more code. So from that point of view, yeah, it's potential for more bugs and also security problems. But I think it's code that's worth it. And the other thing that every programmer knows is that if you change something, it's probably broken something else, some other part of the program that you weren't thinking about. And so the really nice thing about having lots of tests that run every time you do anything is that it checks all the stuff that you've forgotten even exists, instead of just trying it out immediately after you wrote it.
Now, there are different ways to test things, right? There are like unit tests and integration tests and end-to-end tests, and I don't know what else. What are all those?
And you've also got regression tests, like Andy just mentioned.
Yeah, there's loads of different types, and they have different names. But I think the big distinctions are what people often call unit tests, which generally should be a test that only tests your code and doesn't require like databases or disks or any stuff like that to exist. Generally, some people write unit tests that do, but I would argue that those are not really unit tests. They're probably something like an integration test or a system test. So those other tests might require disks and databases and stuff like that, and they tend to test things that are much bigger and that involve connecting together different parts of the system. So those types of tests are much more valuable because they check that it really works when you've got a real database or you've got two different systems talking to each other or whatever it is. But they're also much slower, much more prone to going wrong. And when tests go wrong, then they waste your time trying to follow up why they went wrong when they're just flaking. So generally, the argument is you should bias towards lots and lots of unit tests because they're really reliable, really fast. But you've got to have the other kinds because those are the things that really check that your stuff works.
Yeah, so the way I've always thought about it, and maybe I'm misusing terms, but unit tests are those that test your actual code, right? The little tiny units of your code. Whereas integration tests use your code, as in they will use it like a consumer would. And then you have your full end-to-end tests, which are essentially from the client's perspective, exactly as the name implies. It goes all the way through the system and all the way back out, and you're testing all the way through. Now, I'm going to play a little bit of the skeptic here, where I do enjoy tests and I do have lots of regression tests and I use tests all over the place. However, I've also found that testing can turn into a little bit of a kind of like a dogma, or where people will start to write the tests purely for the sake of writing the tests and not be like they lose sight of what it is that they're actually trying to gain by writing the tests. So they'll chase something like, let's say, test coverage or line coverage of those tests. They'll chase that magical 100%. Or they will start testing things that actually don't necessarily need to be tested. For example, I have seen before tests being written in, for example, Rust, where someone will write a unit test that tests whether or not the standard vector push method works, right? Adding a unit to a vector actually functions. That's the job of the standard library to test that. That's not the job of your library, your crate, or your binary to test those sorts of things. But it feels productive. It feels like you're writing something and you get another nice green check mark when you run cargo test. So sometimes it feels productive and it's more lines added. However, I feel like some of those types of tests, when people chase those types of numbers, they either chase the number of tests or lines tested, things like that, they can start to lose sight of the actual goal of the test itself.
It seems like when you're starting to write tests, it's best to think about how the particular portion of code you're testing is actually going to be used when the end user is using your application. And that's what you want to test for. You don't necessarily want to test for extraneous stuff that the user might not want to do.
I would say for an integration or an end-to-end test, absolutely yes. But I think there's a lot of tests, especially when it comes to unit testing, where what you're actually testing, it's not seen by the consumer at all. In fact, it might just be an internal implementation detail. Now, that can also have a downside of you can sort of solidify the actual implementation that you have currently used. And you can actually make it harder to change later on, kind of by accident, where you want to change a particular implementation detail and now your test failed because you're doing something differently than you were before. That could be said that your test was initially incorrect and that you were testing the implementation and not the actual output. But those are all semantic games, I guess you can play.
And it seems like in a test-driven development approach, in that situation, rather than changing the implementation first, you should change the test first and then adjust the code so the test passes.
Yeah. So let's talk a bit about test-driven development, right? But first of all, Amalith, I wanted to ask you Kevin mentioned that it can get a bit dogmatic. So as someone with less exposure to this testing stuff, from the outside, do you see that kind of religious war happening over this type of stuff?
I don't think I've seen it personally, but I have seen and heard that it happens. And I would like to avoid that.
So I think a lot of people like me, once you get into testing, get really enthusiastic about testing. And that's always then ripe for a religious war, right? If you get too enthusiastic about things. So test-driven development is a methodology that is intended to help you end up with lots of really good tests. That's the idea of it. And the argument is, if you write your tests before you write your code, just like you mentioned, Amalith, in that particular thing of changing your test before you change your code, the idea is you end up writing tests that reflect better how you would like your code to be, instead of the test being kind of retrofitted around how the code ended up. And that means you end up writing code that's easy to test. And the argument is you end up writing code that is therefore better. And that's my experience, that generally, if I've written code that's easy to test, that fits with other things that I like about code that makes it good.
A lot of times I will start with the integration test because it lets you see how it would feel to use your library or how it would feel to use the thing that you're going to consume. And you can kind of flesh out your API that way and be like, yeah, okay, this feels really good. Now let me implement it so that this actually works. And that's a really good way to end up with a ergonomic API, is by starting with some of those integration style tests. Now, you have to be careful because if you start and go too much, you're going to end up with tests that never pass. And you do want your tests to be able to pass at commit so that you have a clean repository.
Yeah, so I guess we haven't talked about some of the stuff that maybe these days is seen as obvious, but yeah, like generally I would be looking for all my tests to be passing before I do a commit, and then I'd have a continuous integration build that ran the tests to confirm that. Maybe that's obvious these days, I don't know.
Andy, have you run into many instances where you will have tests that are flaky? I heard you mention it earlier, but is that something that you've run into regularly?
Yeah, so in terms of system tests, I would say the biggest problem that I've encountered is flaky tests. And even if you do your absolute best to write them well, it's still, you have to understand, if you're going to invest in that level of testing, you're also going to need to invest ongoing on figuring out why they're flaking and fixing them. And if you start letting them just be failing all the time, then they become worse than useless. So you have to make that investment, even though sometimes it's hard to argue for.
There's a tool I saw posted on the Fediverse maybe last week called the Wumpus Hunter, and it runs a particular test suite. Whatever tests you tell it to run, it runs them all 1,000 times.
Yeah, I saw that.
And the author said that he finds that a very good way to identify and fix flaky tests.
Yeah, I mean, if my tests ran 10 times without failing, I'd be pretty happy, right, in terms of those system tests. That Wumpus tool was potentially being run on your unit tests, which is supposed to be like ultra reliable and always work because they're completely deterministic. And it was interesting hearing people commenting on that post saying, yeah, I ran it and like the 700th time it failed because it ran out of disk space or something like that, so that was interesting.
Yeah, I've seen flaky tests happen before when your test ends up having dependencies on each other. So like you have some sort of race condition in the different order that the tests are run. And sometimes by using tools that will run your tests all in parallel, we'll point that out pretty quickly. Other times I've seen flaky tests happen because you're using global state and you just don't know it. And it turns out global really is global. It turns out all tests will share that same global state. So that can happen pretty frequently. And it seems like flakiness can inject itself in those areas silently, which can be frustrating, especially if you're not sure what to look out for.
Don't use global state, kids.
Shared mutable state. That's the root of all evil.
And I think in terms of people who have real pain with testing, I don't want to say always, but often I find if I speak to someone who's got a thing against testing or feels that testing kind of locks their code into bad patterns and things like that, I often find it's actually to do with the tests being not very good. And I think something that we often overlook when we're talking about this stuff is learning how to write good tests and design good tests is difficult. And no one gets taught it as far as I can see. And it takes a load of practice and a load of bad experience of all kinds of anti-patterns and bad stuff before you start to understand what makes a test that is going to last. And I think also some people don't have the same attitude to their test code that they would have to their normal code. They don't see it as important to make that code nice and easy to read and stuff like that. And I tend to, if I'm doing a code review, I tend to spend more time reviewing the test code because what I want to see is, does this code really work? And so if I can't understand the test, then I can't figure out whether this code works because I can't read the thing that uses the code. So make sure your test code is good.
I think there's also a thing to be said where tests can help you bring on new contributors if it's an open source thing, or it can help you onboard new employees if it's for work. And it gives people confidence that they can execute the tests, they can commit changes to the code base and have not broken anything. So that's a huge confidence builder. If they know how to run the tests, they can run the tests, and they know that their change did not actually break anything meaningful.
Absolutely. And that's a huge confidence builder for anyone working in the code base, especially if it's a bit difficult. I was working a while ago on a rich text editor built from scratch, which is a sort of surprising challenge to take on, I think. But we took it on and we handled some really hairy stuff. You know, what happens when the user selects across a paragraph, part of which is bold and part of which is got in a different font or, you know, whatever it is. And then they press delete and you have to join those two blocks together, right? It gets really hairy. And we had a really comprehensive set of tests with actually a really nice little domain-specific language for describing the state of the text box before you started and after you finished, which made testing an absolute joy in that code base. And so we had loads of confidence, even in this really nasty code, that it actually did what it was supposed to do. And when there was a bug, we could easily recreate it by just using this little domain-specific language to describe the situation and then what the user did, and then see that it definitely is fixed when it's fixed.
Okay, this episode is sponsored by Kolide. What do you call an endpoint security product that works perfectly but makes users miserable? A failure. The old approach to endpoint security is to lock down employee devices and roll out changes through forced restarts, but it just doesn't work. IT is miserable because they've got a mountain of support tickets, employees start using personal devices to get their work done, and executives opt out the first time it makes them late for a meeting. You can't have a successful security implementation unless you work with end users. That's where Kolide comes in. Their user-first device trust solution notifies users as soon as it detects an issue on their device and teaches them how to solve it without needing help from IT. That way, untrusted devices are blocked from authenticating, but users don't stay blocked. Kolide is designed for companies with Okta, and it works on macOS, Windows, Linux, and mobile devices. So if you have Okta and you're looking for a device trust solution that respects your team, support the show and go to kolide.com/LinuxDevTime to watch a demo and see how it works. That's kolide.com/LinuxDevTime. Quick bit of admin then. First of all, thank you everyone who supports us with PayPal and Patreon. We really do appreciate that. If you want to join those people, you can go to linuxdevtime.com/support. And remember that for various amounts on Patreon, you can get an advert-free RSS feed of either just this show or all the shows in the Late Night Linux family. And you also get quite a lot of episodes a day or so early. And if you want to get in contact with us, you can email show@linuxdevtime.com.
How long do you think your unit tests should run for, or should take to run, rather?
I think it would be good if they were fast enough that you could set your editor to run them every time you save the file.
I agree. That would be amazing.
200 milliseconds?
Sure. As fast as possible.
In practical terms, if it takes over, say, 3 seconds, then you're unlikely to do it absolutely every time you could. So anything over that is like, you're wasting my time. And if it takes like 30 seconds, you're definitely going to go browse the web and you're going to lose your place.
Yeah, before you know it, you spent an hour looking at YouTube shorts.
So I think a lot of the places I've worked, the test suites take much longer than 3 seconds, that's for sure.
Well, it depends which suite, right?
Absolutely. And so we would have different levels of test suites too. We would have ignored tests, and we would have tests that we know are very slow. So you would only run those in CI, or only when you know, like, all right, hey, this is about to be good. But sometimes that leads to a little bit of a fractured state where it's hard to know that you've run all the tests and all the tests that are appropriate. And you might introduce a break somewhere and you have not run all of the tests. And you find out later on when you're about to submit the PR that, it turns out some of those ignored tests that you should have run earlier, you did not until now. So that can be a barrier sometimes too.
Absolutely. And it's always a trade-off, right? So like, I feel like you should absolutely have a suite of tests that run in seconds, and you should be really vicious about removing stuff from that suite when it's slow, even if it shouldn't be slow, because there's no reason why that should be, you should just get rid of it or fix it. If you have a big, long project, you are going to end up with tests that take hours to run, and they are still going to be valuable. And you have to make the trade-off between, if it takes 15 minutes before I can merge my pull request, even though it's an urgent pull request, is 15 minutes okay? Is 30 minutes okay? Is 2 hours okay? I would say somewhere between 15 minutes and 2 hours, there's definitely a cutoff, and it's not okay.
This also ties back a little bit to our CI discussion a long time ago, but I found it also really, really helps whenever you submit the PR to have the appropriate tests run. And at least during the PR, maybe on merge to main, you run everything, but at least during the PR, only running the tests that are necessary. Because if you have a CI test suite that takes 30 minutes, an hour, 2 hours, whatever it is, you're very unlikely to want to push that last little fix that you really should probably push if you know it's just going to reset that timer. Now, that last little fix may only be a typo. That doesn't need to rerun all of the tests.
Again, it takes investment, right, to have a good situation, and it's worth it, right? So one of the investments you have to make is which tests are important enough that they get to be in the 15-minute suite, and which ones have to wait and only run once a week or overnight or whatever it is. And another investment you can make is, how can we make these tests faster so that we can run more of them? But both of those things take time, and they take buy-in from whoever's telling you what to do, but they're worth it.
Andy, do you have any experience working with the sort of like automated distributed systems testing frameworks? So these are ones that will model distributed systems, but locally. So they will simulate things like they'll simulate the network. That way you can test a lot of edge cases on something that would normally be really difficult to test, because networks, as we know, is difficult to say the least.
I don't think I've used one of the frameworks that make this easy. I've definitely done it manually, right? So we had one project, we had a massive suite of tests that fired up like 40 Docker images. I was absolutely determined it would run on one machine. So like all the devs got extra memory so that it could run on one machine. And we did things like simulating network problems and slowness and stuff like that in that suite. But are there better ways? We kind of just did it ourselves, I think.
Yeah, all the places that I've worked so far, we've done the exact same thing. We do it manually, do it ourselves, introduce network problems via things like TC, which thankfully Linux has stuff like that lets you simulate those types of things. But using one of those more simulated frameworks has always been on my to-do list. I just haven't had the chance to do it yet.
Now, when you're testing things like a web application, do you go as far as spinning up a whole headless browser to actually interact with that web application? Or do you figure out other possibly lighter ways to test interacting with it?
I've never worked on front end stuff to that degree. So some of what I'm going to say is either speculation or having talked to my colleagues who do that. And to an extent, yes, they will do like user testing, or one person in particular that I'm thinking of, they would even have, it was like a screenshot type functionality where the test would actually screenshot internally what it looked like, so that they could go back later and either visually diff it, or if something went wrong, they could look and be like, oh, yeah, that's absolutely not correct. I don't know how automated that was, though.
So, yeah, I think this is another real good reason to use test-driven development, because if you structure your code in the right way, you can test a load of stuff without needing to go to a real browser. But there's no doubt, there's no way that I'm aware of testing like that your CSS combines correctly with your HTML to make it actually look the way it's supposed to look. So yeah, I've done several projects with headless browsers where you take a screenshot and you diff it pixel for pixel against your reference screenshot, and it's a nightmare because if there's an operating system upgrade or whatever, then it's different and it's just awful. But what else can you do? If you want to know it works, you got to do it. Have any of you heard of mutation testing?
No, I don't think so.
No.
So mutation testing is a really interesting way to find out whether your tests cover all the stuff that they should cover. Because mutation testing, it takes your tests and your code and it modifies your code in different ways. But essentially it introduces bugs and then it checks whether your tests found the bug, right? And then it says, well, actually, you haven't tested this because I was able to add a 3 here and your test still passed.
It's similar to the chaos engineering kind of.
I was literally about to ask about chaos engineering. Is there anything like that for code? Chaos engineering as a term seems to cover more infrastructure stuff, but that would be great for code as well.
Yeah, I would say mutation testing is at the unit test level is kind of a similar thing to the Chaos Monkey. We should probably say what that is, right?
I was about to say, for those who don't know, chaos engineering and chaos monkeys are the people who do the chaos engineering, or chaos engineers, whatever you like. That's just blowing things up to see what breaks. Turn off a server, disable a network, shut down a VM, just cause chaos and see if you can handle that. And if you don't handle it as well as you should, go fix it. Write a test. Something like that.
It's pretty awesome. And it's interesting when you work at the scale where stuff is going to be breaking all the time, then introducing the Chaos Monkey is no longer so risky as it sounds. Like if you're a small shop and you might break everything, but if you're running hundreds of servers, then stuff's going to break all the time. So just like making sure that all the different types of thing that could break regularly break, and therefore everything is fine when they do, is kind of a sensible strategy.
So the other question, elephant in the room, binary files and tests. Yes or no? Where do we stand?
What kind of binary files?
The kind that you can't read in a text editor.
So you mean anything? Like because for example, screenshots, right? There would be binary files that you're using as references.
Yes.
Those can also have vulnerabilities in them, I think. Sort of. Exploits, at least.
I mean, they could do. You could have, depending on the image format, right? There's some vulnerabilities that can be stuck in there.
I think my answer would be, at some level, you're never going to be able to get away from all vulnerabilities.
Yeah.
So if your actual test suite really does rely on binary files, at some point, you're probably going to have to trust them or trust the contributors that contribute them. That's probably why, signed commits and things are a good idea. But I think we all are a little bit scarred based off of recent-ish events in binary files and tests and what kinds of hazards they can present.
I would certainly say if you're working on anything that has security implications, having the simplest possible build and release process that is understandable and doesn't do anything weird is really, really important, right? So for example, you could say my build and release process doesn't run any tests and doesn't even have any of those binary files that are needed for tests, but my test process does, or something like that.
Yeah, or if you have a reproducible way to build the binary data. So perhaps the binary files themselves don't live in the repo, but you do have a set of scripts or something that will generate those binary files, run the test against them, and then delete them. I think something like that could possibly also be a way forward.
One of the things I was thinking about was I want to include a SQLite database in my repository for having real-world data to test with. And instead of having just the SQLite file itself, it could instead be a SQL script that we import to a SQLite database during the test and then delete it afterwards. Delete the resulting database afterwards, but retain the plain text version.
That's actually another really good point is the data that you use to test on when it's especially in a database. There are, I think, several different methods of thought. Some of it is generating the test data live, i.e. some scripts that just inject a bunch of data. But then there's the question of how like your real production data is that randomly generated data. Other people I've heard of actually using production data in tests, just copies of it or branches of it if your database supports such a thing. So I think there's a bunch of different ways to go after that problem, none of which is necessarily better than the other. It's all trade-offs.
Yeah, I've definitely worked with projects that have a DB dump as part of the testing process, and sometimes you just have to do it. But if you can possibly avoid it, the worst thing about it, I think, is you get stuck. If you need to change your test or if your database structure changes or you just need some new data, it's just a massive hassle to update that DB dump. But if it was built from scripts, then it would be straightforward to just make updates and treat it like code, basically.
And then there's all kinds of like PII concerns too. If your data actually has PII in it, you have to have some way of scrubbing that prior to test, because you don't want that to show up in like outages on CI and GitHub or GitLab.
Replace usernames with something else.
Yeah, and if the scrubbing was just done by some person who thought they knew how to scrub things, then they probably did not scrub it very well.
Right, well, we'd better get out of here then. We'll be back in a couple of weeks, but until then, I've been Joe.
I've been Amalith.
I've been Kevin.
And I've been Andy.
See you later.